Hi everyone, I am JULKA. Today's topic is probability. When we talk about probability, there are three types: classical, relative, and subjective. But today we'll discuss only classical approach of probability. We will assume all outcomes are equally likely. Under classical approach to probability, probability of an event equals to number of outcomes favorable to events divided by total outcomes. Always remember that in classical approach, we assume that the outcomes of the experiments are equally likely. And always remember some points. The probability of any event always lies between 0 to 1. The probability of sample space always be equals to 1. And if A and B are mutually exclusive exhaustive events, then probability of A union B equals to probability of A plus probability of B, which equals to 1. Now I'm starting with the example of a coin. A coin is tossed twice. Find the probability of two heads, one head, at least one head, and none head. A coin is tossed twice, so chances are 4. We can write sample space, head head, head tail, tail head, and tail tail. So we have 4 events. Starting with the first point, probability of 2 heads. The number of events favorable to 2 heads is only head head. So 1 event. So the required probability is 1 by 4. Next, probability of 1 head. 1 head means either we have head or tail or tail or head. So we have 2 events. So the required probability is 2 by 4. Next part, probability of at least 1 head. At least 1 head means minimum 1 head. So maybe we have 1 head or 2 heads. So when we use or, we use plus sign in place of or. So 1 head plus probability of 2 heads. Probability of 1 head is 2 by 4. Probability of 2 head is 1 by 4. So the answer is 3 by 4. Next, probability of none head. None head means both tail. Both tail means we have only one chance, tail and tail. So the required probability is 1 by 4. Now the next question on dice. A pair of dice is thrown once. Find the probability of doublet, even on first die and odd on second, and even on one and odd on other. A dice is thrown twice, so total events are 6 is to the power 2, 36. First, we have to find the probability of doublet. Doublets are either 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. We have 6 events. So probability of doublet is 6 by 36. Next part. We want to find out probability of even on first and odd on second. Even on first means either we have 2, 4, 6 on first, and odd on second means we have 1, 3 and 5 on second. So we have combination 2, 1, 2, 3, 2, 5, 4, 1, 4, 3, 4, 5, and 6, 1, 6, 3, 6, 5. 9 events favorable to this. So the required probability is 9 by 36, which equals to 1 by 4. In the next part, we need even on one and odd on other. This implies if we have even on first, then we have odd on second. If we have odd on first, then we have even on second. So we have double cases. In place of 2, 1, 2, 3, 2, 5, we have also 1, 2, 3, 2 and 5, 2. And then we have 4, 1, 4, 3, 4, 5. Then we have reverse of that 1, 4, 3, 4, 5, 4. And then we have 6, 1, 6, 3, 6, 5. We have a reverse of that 1, 6, 3, 6 and 5, 6. So total chances are 18. So required probability is 18 by 36, which equals to 1 by 2. Now next question on cards. 4 cards are drawn at random from a pack of 52 cards, one by one with replacement. Is a question of with replacement. Find, first point, probability of all cards of same suit. When we talk about suits, we have 4 suits: heart, diamond, spade and club. So either all 4 cards of heart or diamond or spade or club. So the required probability of all heart is 13 by 52 raised to the power 4, plus probability of all diamond is again 13 by 52 raised to the power 4, and so on 4 times. So the required probability is 1 by 64. Next part, probability of all cards of different suits. When we say different suits, this implies we have 1 heart, 1 diamond, 1 spade and 1 club. And after that we have to arrange this also. So the required probability is 13 by 52 multiplied by 13 by 52 multiplied by 13 by 52 multiplied by 13 by 52 into 4 factorial, because we want to arrange this also. So the required answer is 3 by 32. Next part, probability of all cards of different suits and different denomination. When we say different denomination, means the numbers are different. Suppose if we draw first card king, the second card cannot be king. Suppose the second card is queen, the third card is cannot be king or queen. If the third card is jack, then the fourth card is neither king nor queen nor jack. So the required probability is 13 by 52 into 12 by 52 into 11 by 52 into 10 by 52 into 4 factorial, because we want to also arrange them. Next part, probability of ace, king, queen and jack respectively. When we say respectively, the order cannot be changed. The probability of ace is 4 by 52, king is again 4 by 52, queen is 4 by 52 and jack is 4 by 52. So the answer is 1 by 13 whole raised to the power 4. Next part, probability of an ace, king, queen and jack. The difference between this and the previous part is, here we can arrange them also. So when we arrange, always multiply by n factorial. Here we have 4 cards to multiply by 4 factorial. So the required probability is 4 by 52 into 4 by 52 into 4 by 52 into 4 by 52 multiplied by 4 factorial. So the required answer is 24 multiplied by 1 by 13 raised to the power 4. When we solve this question using without replacement, then we can use combination. And always remember that when nothing is given about replacement, we assume it's a question of without replacement. Now 4 cards are drawn from 52 cards without replacement. Find the first part, probability of all cards of same suit. We know that we have 4 suits. First of all, out of 52 we choose 4 cards. So total chances are 52C4. So maybe we have 4 hearts, 4 diamond, 4 spade or 4 club. So that's why we use plus here. So when we say 4 heart, this is 13C4. Similarly 4 diamond, 13C4. 4 club, 13C4 and the 4 spade, 13C4. Next part is probability of all cards of different suits. When we say different suits, this implies 1 heart, 1 diamond, 1 spade, 1 club. Total chances are 52C4. So when we say 1 heart, 13C1 and means multiply, then is 1 diamond, 13C1 and means again multiply. We need 1 club, 13C1. We are choosing 1 club out of 13. And last 1 spade, again we are choosing 1 spade out of 13, is 13C1. Next part, probability of all cards of different suits and different denominations. The number must be different. So in denominator we will get the total events 52C4. But when we draw the first card from heart, it is 13C1. From this cards we will get king. So in the next diamond one, we have only 12 options. So chances are 12C1. Similarly, the next one is 11C1 and the last one is 10C1. We use multiply here because they are different. One from heart, one from club and one from spade and one from diamond. Next part, We want to find out the probability of ace, king, queen and jack respectively. So when we use respectively, the order is given. So when any condition is given, never use combination. First is ace, 4 by 52. Next is king. King is 4 by 51. Why 51? Because we already draw one card. Next part is queen. Queen is again 4 by 50 because we already draw two cards. Next part is jack. Jack is 4 by 49. We already draw 3 cards. And if we want to find out the probability of ace, king, queen and jack, this implies order is not given. There is no condition. So we can use combination here. Total chance of 52C4. Out of 4 ace, we choose 1 ace. Out of 4 king, we choose 1 king. Out of 4 queen, we choose 1 queen. And out of 4 jack, we choose 1 jack. So the probability is 4C1 into 4C1 into 4C1 into 4C1 divided by 52C4. If A and B are mutually exclusive events, this implies there is nothing common between two. For example, even number and odd number, there nothing is common between these two. Then probability of A union B always be equals to probability of A plus probability of B. And if A and B are non-mutually exclusive events, then probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. We can explain with the help of an example. A card is drawn at random from a pack of 52 cards. Find the probability of a king or red card. Let A denote a king and B denote a red card. Now A and B are non-mutually exclusive events because something is common between king and red cards. So probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. Probability of A king is 4 by 52. Probability of red card are 26 by 52 minus common cards are 2. So the probability of A intersection B is 2 by 52. So the required probability is 28 by 52. Now we talk about independent events. If A and B are independent events, then probability of A intersection B is probability of A into probability of B. Here, the probability of A does not affect the probability of B. Now the last example, the probability of A to solve a problem is 3 by 5 and the probability of B to solve a problem is 4 by 5. Find the probability one of them solve the problem and also find problem is solved. We have to find the probability the problem is solved. Now, it is given that probability of A is 3 by 5. So, what's the probability of not A? Not A is 1 minus probability of A, which equals to 2 by 5. Probability of B is given 4 by 5. So, what's the probability of not B? 1 minus probability of B, which equals to 1 by 5. First of all, we want to find out probability of one of them. One of them means A solve the problem, then B not. Or B solve the problem, then A not. So, we can write this way. Probability of A and B not or probability of B and A naught, which equals to probability of A into probability of B naught plus probability of B into probability of A naught. By inserting the value of probability of A, probability of B naught, probability of B and probability of A naught, the answer is 11 by 25. Next part, the probability of problem is solved. When we say problem is solved, this implies the problem is solved by at least one of them. Or we can say at least one of them solve the problem. This equals to 1 minus none of them solve the problem. None means neither A nor B. So not A and not B, which equals to 1 minus probability of not A into not B. And after putting the value, you get the answer 23 by 25.